All right, this is 8.1, evaluating nth roots and using rational exponents. So let's go ahead and start out looking at something that we already know, like 2 to the third power. We know that that just means 2 times 2 times 2, which equals 8. We also know how to take the square root of a number. So if we have the square root of 9, we know that that means what number times itself equals 9. So really, what it's asking is what the second root of 9 is. We just don't write the 2 when it's the second root because it's so common to take the square root. Well, really, we know that the second root of 9 is 3 because 3 times 3 equals 9. But now we're going to be looking at higher roots like we have here. The root here is 3. So this is the third root of 8. And what this is saying is what number times itself 3 times equals 8. So we know that 2 times 2 is 4 and 4 times 2 is 8. So the third root of 8 is 2. All right, and we have this written out here in variables. So b raised to the power of n equaling a is the same thing as a to the nth root equaling b. Okay, moving on. Now we're going to be looking at changing between radical form and rational exponents. And so rational exponents just means our exponent is going to be a fraction. Okay, so we have a to the nth power. We can write that as a raised to the 1 over n power. So I have this little note that I want you guys to write down. The nth root becomes the denominator of the rational exponent. So if we have x, the third root of x, that we could write out in terms of rational exponent as just x raised to the 1/3 power. Or if we had a number, let's do the third root of 64, we could write that out as 64 to the 1/3 power. Okay, so now let's look at going back and forth between these. So we have the square root of 9. We already said that there's technically a 2 here. So this is just 9 raised to the 1/2 power. And then we have the fourth root of 81. That's 81 to the 1/4 power. And we have negative 27. So it's important if we're raising that to a power, we put this in parentheses. This would be negative 27 to the 1/3 power. And this one's a little bit interesting. So let's kind of break this down a little bit. We know that this is really saying x to the third power, and we want to take the fourth root. So that would be the same as raising it to the rational exponent of 1/4. And we know from our power rules that if we are raising a power to a power, we just multiply our exponents. So if we do 3 times 1/4, we get x to the 3/4 power. All right, so now we're going to be going the other way with it. So we have 25 to the power of 1/3. We're going to write that as the third root of 25. All right, the next one, have negative 3x. It's going to go inside our radical, and we want the fifth root. And okay, this last one's a little bit trickier. So what's going to be inside our radical? We have the expression y minus 5, but this is going to be raised to the third power, and we're going to be taking the fifth root. Okay, now we're going to be looking at some rules for even and odd roots. But to help us conceptualize this, we're going to look at the powers for 2 and negative 2. So let's start with positive. So 2 squared is just 2 times 2, which is 4. 2 to the third is 2 times 2 times 2, which is 8. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. 2 to the fifth is 2 times 2 times 2 times 2 times 2, which is 32. And now we look at negative 2. So negative 2 squared is negative 2 times negative 2, which is positive 4. Negative 2 to the third is negative 2 times negative 2 times negative 2, which is a negative times a negative is a positive. A positive times a negative is a negative. So this is negative 8. All right. Negative 2 to the fourth power is negative 2 times negative 2 times negative 2 times negative 2. Again, a negative times a negative is a positive. Positive times a negative is a negative. And negative times a negative is a positive. So we're back at positive 16. And last one, negative 2 to the fifth is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Again, negative times a negative is a positive. Positive times a negative is a negative. Negative times a negative is a positive, and positive times a negative is a negative. I might have done that one too many times, but negative 2 to the fifth power is negative 32. Okay, so now if we go and look at the roots here, so the second root of 4, so how do we get 4 as an answer, right? We get it with positive 2 and with negative 2. So we have two answers. We could have 2 or negative 2. All right, what about the third root of 8? We only get 8 when 2 was positive. So we only have one root there. The fourth root of 16, well, 16 we get with positive 2 and with negative 2. So hopefully we're seeing a pattern here that is going to emerge. We get 2 or negative 2. How about with the fifth root of 32? We only get that with positive 2. All right. And so hopefully we're recognizing here that we have these positive, or sorry, not positive, but these even roots will have two roots. And when we have odd roots, we only have one real root. Okay. All right. Now we've got some negatives. So the second root of negative 4, so this is saying like what number times itself equals negative 4? Well, when we had 2, positive 2 and negative 2, those both came out as positive 4. So we know we can have imaginary numbers, but there's no real root for negative 4, square root of negative 4. What about the third root of negative 8? We did get that for negative 2. All right. And negative 16, again, with 16, we got only positive and negative. We only got a positive 16. So again, this is going to be no real root. And with the fifth root of negative 32, we were able to get that with negative 2. Okay, so hopefully this conceptualizes and makes more sense when we write these rules down. Okay, so with even roots, if the a value, the value that's under the radical, if that is less than 0, like a negative, like with the square root of negative 4 or the fourth root of negative 16, there's going to be no real root, right? If a is equal to 0, so if 0 is under the radicand, it doesn't matter if we're taking the second root or the third or the fourth, it's always going to equal 0. So there will be one real root, but that one will equal 0. All right, and then if a is greater than 0 with even roots, like let's say the square root of 4 or the fourth root of 16, we're going to have two real roots. Now on to odd roots. If the a value is less than 0, like with this example here, the third root of negative 8, we have the a value, oops, turn my pen over, a value is negative 8 and our root is odd, and we got one root, so one real root. Again, with a is 0, it doesn't matter if it's an even root or an odd root, it's going to equal 0, so there's going to be one real root. And last one, if a is greater than 0 and we have an odd root. So that would be like this example here. We have a value is greater than 0, and we have an odd root, and that gave us one real root. All right, so let's move on. Let's look at some practice problems now. All right, example 1. Let's start out with an easy one. How about if n is 2 and a is 64? All right, so this would be written like this. You know, if it's typically if the root is 2, we don't write this, but I will for this problem. So we have if the a value is greater than 0, we have an even root. So, you know, normally we would just say, oh, well, the answer is 8 here, but we have two real roots because we have an even root. So this is -8 and +8. All right, example 2, let's go with n is equal to 3 and a is equal to -27. So that's going to be the third root of -27. All right, and now we have the a value is less than 0, and we have an odd root. So we will only have one real root, and that would be -3. All right, example 3, how about n is equal to 4 and a is equal to -16. All right, there we go, that's set up. All right, so the a value is, maybe we should pull this sheet up. There we go. So the a value, -16. Can we get this whole thing? So the a value is less than 0, okay? And it is an even root. 4 is an even number, so that means there's going to be no real root for this one. All right. So when you're looking at problems like that, just refer to this little chart and you should be good. Now, examples 4 and 5. So we're just going to simplify this, the sixth root of 64. So what I do is I do this kind of upside down division here. And if you're not sure where to start, I always say like either cut it in half, divide it by 3, whatever you can, sometimes 5. Just try to make it smaller. For 64, obviously it's even, so I know I can cut it in half. So I divide that by 2 and I get 32. Cut that in half. Can cut that in half. Still keep going and down. And look at this. We got 1, 2, 3, 4, 5, 6. So the sixth root of 64 is 2. All right, example 5. This one's not written right. I want this as the fourth root of 16. So, and then this is all raised to the -7th power. So what we want to do is simplify inside the parentheses first. So again, we're going to do this upside down division here. So let's cut it in half. 16 divided by 2 is 8. 8 divided by 2 is 4. 2 divided by 2 is 2. And look at that, we got 1, 2, 3, 4. So if we're just simplifying inside the parentheses, the fourth root of 16 is 2. And now we're going to take that to the -7th power. And remember, if we have a negative, we don't like negative exponents, so we want to rewrite this as a fraction with 2 to the +7th in the denominator. And now we could actually multiply this out. 2 to the 7th power is 128. So we could just simplify this and do 1 over 128. And obviously, you could use your calculator to check that one. All right, moving on to the back page. All right, example 6, we have -27 to the 2/3 power. So let's go ahead and write this as a radical. It's going to be -27 is going to be inside our radicand. It's 7. All right, and so remember the denominator is your root, and this whole thing is going to be raised to the second power. Okay, so what we want to do is figure out inside the radicand first. So how can you break apart -27? So let's just look at this part. -27 we could break down into -3 times 9. And 9 we could break down into -3 times -3 times -3. And so there we go. Now we know that is correct. So we have 1, 2, 3. And that's really what taking the root of something means. So this reduces down to -3. Got to remember, we're still going to square this at the end. So -3 squared is -3 times -3, which is +9. All right, example 7. We got 1 over 81 to the -3/4. I don't like a negative exponent, so I'm going to write that as a positive exponent in the numerator. All right, now I'm going to convert this to radical form. So it's going to be the 4th root 81, all raised to the 3rd power. So now we can simplify inside the parentheses. So I want to figure out what the 4th root of 81 is. So if I think about that, what number times itself 4 times equals 81? Well, it ends in a 1, so it's got to be an odd number. So I'm guessing 3 is going to work. But if you actually want to write this out, we could break this 81 into 9 times 9. And then we could further break apart each of those 9s into 3 times 3 and 3 times 3. And so here we can see that the 4th root of 81 has to equal 3 because we have 1, 2, 3, 4 3's. It's the same number. So the 4th root of 81 is 3. And don't forget, we still have to take this to the 3rd power. So 3 to the 3rd power is 3 times 3 times 3, which is 27. All right. Next couple, we're just going to be using our calculator to evaluate. Round to the nearest 2 decimal places. Okay, so the nearest 100th. So I'm going to go ahead and convert this into a rational expression, and then we'll figure out both answers and show that they are equivalent. This would be the same as 187 raised to the 3/4 power. And so let's now pull up our calculator and show that we'll get the same answer. So if I type in this first expression as a radical, I'm going to hit 4, then the second key. I'm going to hit this button here to get this second function right there. All right, 187 goes in our radical. Then I want to come out of here and raise this up to the 3rd power. And I get 50.568, so we'll call this 50.57. All right, and let's also show that we can get the same answer with the rational exponent. So if we do 187 and we raise this to 3/4 power, press enter, there we go, exact same answer. So either way you do it, we're going to get the same answer. All right, number 9, we can just type this right into our calculator. Oops. Let me get the large screen going. There we go. So I want to type this whole thing in. So let's start out with a fraction. We'll do 1, go into the denominator. We have a -17, so I'm going to make sure to put the parentheses so the calculator will recognize the negative. Close the parentheses, and now I will raise it to the 3/5 power. And press enter, and there we go. -0.182. And we're rounding to the nearest 100th, so we'll just call this -0.18. All right, solve the equation and round to the nearest 2 decimal places. Okay, so for number 10, we've got 2x squared equals 18. So the first thing I want to do is get rid of this coefficient, or I want to get this coefficient equal to 1. So I'm going to divide by 2 on both sides. So I'm left with x squared is equal to 9. Now typically we would just take the square root here, but if we want to solve these with rational exponents, we want to get this number equal to 1, right? So how could I get 2 equal to 1? I could multiply by the reciprocal, 1/2. All right, and this would cancel out. That would equal 1x, or x to the first power. But if I do it to one side, I got to do it to the other side. So there we go. We get 9 to the 1/2 power. And just to solve this out, what could be my two values of x? Well, we know we would get 3, but this is an even root. So we're going to have two answers. This could be 3 or -3. All right, number 11, kind of similar to start. We want to get this 2/3 equal to 1. So I'm going to multiply this by the reciprocal, 3/2. And this will cancel out and equal 1. If I do it to one side, I need to do it to the other side. So now this is going to be 4 raised to the 3/2. Let's go ahead and just rewrite this. Get a minus 10 is equal to 4 raised to the 3/2. And now I can simplify this part here. So this would be, if I want to write 4 3/2 as a radical, that would be, the 2 would be the root, and then we'd be raising this to the third power. We already know what the root of 2 squared would be, or 4 squared that would be 2, and this raised to the third power would equal 8. All right, so now we have a minus 10 is equal to 8. But we should also recognize that our root here was the 2. So that's an even root. So we should have two answers. Okay, so this is going to be like plus or minus 8. All right, so we're going to get a by itself by adding 10. So we're going to have two answers. It's going to be a could equal 10 plus 8, or a could equal 10 minus 8. So a could equal 18 or 2. All right, last couple problems. Number 12. All right, we got x to the 6 plus 36 is equal to 100. So the first thing I want to do here is get rid of this 36. I'll do so by subtracting 36 on both sides. This will cancel out. I'll be left with x to the 6 is equal to 64. So if we want to rewrite this as a radical, we can do that. This would be the 6th root of 64. And now we know that this is an even root. So we're going to have two answers. So this would be 2 or -2. This example for today, we have g plus 10 raised to the 5th equals 70. So the first thing we want to do is get rid of this 5. I can do so by multiplying by the reciprocal, 1/5, and that will equal 1, so it'll cancel out. If I do it to one side, I need to do it to the other side. So now I'm just left with g plus 10 is equal to 70 to the 1/5. And if I want to write 70 to the 1/5 in radical form, that would be the 5th root of 70. And so we have an odd root because 5 is odd. So that means we're going to have one answer. All right, so now we just need to get g by itself. We're going to subtract 10 on both sides. And so from here, we can just type this into our calculator because I know that there isn't a number that we can evenly multiply by 5 by itself 5 times to get 70. So we're going to have to get an approximation here. So let's see. We're going to hit 5 and the second key, and we get the key that we want here by hitting this caret button. 70. Get out of the radical by hitting the arrow button, minus 10. Press enter, and there you go. -7.66. G is equal to -7.66. All right, that's all I got for you guys. That is 8.1, nth roots and rational exponents. Good luck on the practice problems.